everyone and welcome to my channel. Today we have a question which says for complex ion NiCl4 2-, what is the charge on metal and shape of complex respectively? There is a complex NiCl4 2- which is given and we have to predict its charge and the shape of the complex. So how can we predict the charge? It's very simple. So let's suppose the charge on nickel is X and then we have 4 chloroligands, okay? And what is the charge on the chloroligand? That is -1. So we have to multiply 4 ligands -1. Charge on chloroligand is equal to -2. That is the total charge on the complex. So X becomes 4 minus 2, that is +2. So nickel is +2. Charge on the nickel is +2. So nickel is +2 oxidized. Now the electronic configuration of nickel in ground state is 3d8 4s2. Okay. And in the +2 oxidation state, what is the electronic configuration? 3d8 4s0. Okay. We have to arrange these electrons in the 3d orbital and let's see how we get the hybridization and the geometry of this complex. Okay, now I have drawn this 3d 4s and 4p orbitals. So how many electrons in 3d? We have 8 electrons. Okay, what kind of a ligand is chloroligand? Cl. The chloroligand is a weak field ligand. That also is a very important consideration for solving this problem. And weak field ligands, you know, according to crystal field theory, these do not support or these do not favor the pairing of d electrons. Okay, so now we fill 8 electrons in the 3d orbital. So 5, 6, 7 and 8. Okay, now we have 4 chloroligands, right? So 4 chloroligands we have 4 Cl minus ligands. And how many electrons do each ligand contribute? Each ligand contributes to a 2 electron. Electrons into 4 ligands, that is equal to 8 electrons are contributed by the chloroligand, right? And these 8 electrons which are contributed by the chloroligand have to be filled in the 4s and 4p orbital. Okay, so why 4s and 4p orbital? Because we have seen that chloro is a weak field ligand and it will not favor the pairing of these remaining 2 unpaired electrons of the nickel in the 3d orbital. So these 2 electrons, 2 unpaired electrons of nickel in the 3d orbital, they remain unpaired. They are not paired because nickel is bonded to a weak field ligand, that is chloroligand. Now, in the 4s and 4p orbital, we now fill the electrons which are contributed by the chloroligand, 8 electrons. Okay, 1, 2, 3, 4, 5, 6, 7 and 8. Okay, and that is why now the hybridization becomes sp3 hybridization. 1 4s orbital and 3 4p orbitals. So the hybridization becomes sp3 hybridization. Okay, and sp3 hybridization gives a geometry of, you know it very well, sp3 hybridization means the geometry is tetrahedral, indicated by short form TD also. In many places you must have read. So what is the answer of this question? The charge on nickel is +2 and the shape of the complex is tetrahedral. And how it is tetrahedral? Because nickel is coordinated to a weak field ligand chloro, and because of that the 2 lone pairs of nickel are not paired. They remain unpaired because weak field ligands, they do not favor pairing of d electrons. And that is why the 8 electrons which are contributed by the chloroligand are accommodated in the 4s and 4p orbital. And so we have a hybridization of sp3 hybridization, which gives us the geometry of tetrahedral for this complex. So what should be our answer? Our answer should be option 1 +2 charge on nickel and tetrahedral geometry. So I hope you understood the explanation of this problem. It's a very straightforward question and not a very difficult one. You have to just understand the nature of the ligand for this complex. And if you have any queries, you can write to me in the comment section, and please do not forget to like, share and subscribe if you find my videos helpful for you. Till then, keep learning, keep watching, and see you soon with the next problem.